Welcome to this tutorial on stacking arrays with np.dstack. In this video, we'll explore how to stack arrays along the third dimension, which is a powerful technique for organizing multi-dimensional data in NumPy. np.dstack is a NumPy function that stacks arrays along the third axis, also known as the depth axis. This creates a new dimension that extends into the depth of the array structure. Think of it as layering arrays on top of each other, similar to stacking sheets of paper. To understand np.dstack, let's review NumPy's three primary axes. Axis 0 represents rows and handles vertical stacking. Axis 1 represents columns and handles horizontal stacking. Axis 2 represents depth, which is where np.dstack operates, layering arrays to create three-dimensional structures. The syntax for np.dstack is straightforward. First, import NumPy as np, then call np.dstack with a tuple of arrays as the argument. The function takes multiple arrays and returns a single stacked result along the third dimension. Let's look at a simple example. We create two two-dimensional arrays. Array A contains the values 1, 2, 3, and 4, while array B contains 5, 6, 7, and 8. When we call np.dstack with A and B, the resulting shape is 2 by 2 by 2, indicating 2 rows, 2 columns, and 2 layers in depth. The result structure shows how the arrays are stacked. Each position now contains pairs of values from the original arrays. Position 0, 0 contains 1 and 5, position 0, 1 contains 2 and 6, position 1, 0 contains 3 and 7, and position 1, 1 contains 4 and 8. The values are paired along the third dimension. np.dstack has many practical applications. It's commonly used for combining RGB color channels into a single image array in image processing. It's useful for stacking multiple two-dimensional data matrices for batch processing. In machine learning, it helps create three-dimensional tensors for neural network models. Scientists also use it for combining multiple experimental data layers in research applications. Let's recap the key takeaways. np.dstack stacks arrays along axis 2, which is the depth dimension. It creates a three-dimensional array by layering two-dimensional arrays together. This function is essential for image processing and working with multi-dimensional data. Understanding np.dstack gives you powerful capabilities for organizing and manipulating complex data structures in NumPy.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.